5.1 is continuing with more verifying and factoring and other tools to use in that process. So for this first part, you're going to factor these. So I do realize that secant squared x minus 1 could become tangent squared x using that Pythagorean identity, but that's not what it asks for. I'm asking you to factor. So this is the difference of two squareds, just like you might see x squared minus 9 that you would tell me is x plus 3 and x minus 3. This is going to become secant x plus 1 and secant x minus 1. So I have that factored. That's it. I'm done. On the second one, you factor it just like you would of a quadratic. So if it helps, think of it as 4x squared plus x minus 3 and factor that out. Then turn it back up into your tangent squared. But you should be saying numbers that multiply to negative 12 and add to 1. So I'm going to keep my 4 tangent squared x. Multiplying to negative 12, adding to 1 should be 4 and negative 3. So I have 4 tangent x minus 3 tangent x minus 3. If you were down here, you would have told me still negative 12 adds to 1. So I can split this guy into 4x minus 3x minus 3. If you have another method you prefer to factor with, that's fine as long as you can do it correctly consistently. From there, I factor by grouping. So out of these first two, I can factor out a 4 tangent x. I'm left with tangent x plus 1. Out of the second group, I can factor out a negative 3. I'm left with tangent x plus 1. Similarly, if you were down here, you'd factor out a 4x, be left with x plus 1, factor out a negative 3, be left with x plus 1, which would turn into 4x minus 3 and x plus 1. Up here, my two factors are 4 tangent x minus 3 and tangent x plus 1. Over here, looks like a normal quadratic. Oh no, this is cosecant squared. That's cotangent. Can't have two different trig functions happening, so I need to rewrite one of them. It's almost always going to be easiest to rewrite the one that's squared by looking at your Pythagorean identities. So if I look at that list, cosecant squared is 1 plus cotangent squared x. So I can just replace that, bring down my minus cotangent x and my minus 3. Then I go ahead and combine like terms with my negative 3 and my 1. And then I can factor. So I have cotangent x minus 2 times cotangent x plus 1. If you got stuck at this point, factor it like you would have x squared minus x minus 2, which would be x minus 2 and x plus 1. But instead of x, it's cotangent x. Okay, so when we're rewriting it so it's not in fractional form, we're basically just trying to get rid of the fraction. Whenever you have a fraction that has addition or subtraction in the denominator, so you have two terms, the tool you are going to use is to multiply by the conjugate of the denominator. So my conjugate, since this is 1 plus sine x, is simply 1 minus sine x. Make sure you multiply both the numerator and the denominator by that so that it's just like multiplying by 1. In my numerator, 1 times 1 minus sine x is 1 minus sine x. In my denominator, when I multiply that out, 1 times 1 is 1. I'm going to have negative sine x plus sine x, so those will cancel. And then sine x times negative sine x is negative sine squared x. That, by the way, is like the complete backwards working of your factoring difference of two squareds. From there, 1 minus sine x cannot really be simplified, but 1 minus sine squared x is cosine squared x. So you might look at this and say, that does not look any more simplified than where I started. It doesn't, I agree. But what's nice is now that that addition and subtraction, whichever one it is happening in the numerator, you can use a tool called splitting the numerator. You are not able to split the denominator, but you can split the numerator. So I'm going to split it so that it's 1 over cosine squared x minus sine x over cosine squared x. 1 over cosine squared is secant squared x. Sine over cosine would be tangent. That does still leave one of these cosines in the denominator. And if that helps, think of it like this: sine x over cosine x times 1 over cosine x. Like, these are the same thing. So that cosine x being the denominator is just like a secant x. Yes, I could factor secant x out of there. That won't really help a whole lot, because then I'd still have secant x minus tangent x. But I look back at my directions, all I had to do was get it so that it wasn't a fraction. You are going to be using substitution in this problem to rewrite this using a trig function. So I have this 4 plus x squared. I have being between 0 and pi over 2 to basically tell you that everything is positive. Sine, cosine, tangent, cotangent, cosecant, secant, whatever is all positive. And instead of x, you're going to put 2 tangent x. So now I have 4 plus, instead of x squared, I have 2 tangent x squared. So I'm going to want to go ahead and just square that. So I have 4 plus 4 tangent squared x. Now, while you might look at this and say the square root of 4 is 2, and the square root of 4 tangent squared would be 2 tangent, you can't square root those two terms. That plus sign means you can't just square root each of those. So I have to somehow turn this into multiplication. Or two things multiplied to equaling that, which would be like factoring something out. So I could factor 4 out, and now I have 1 plus tangent squared x, which is very helpful, since if I look at my trig identities, specifically my Pythagorean theorem, Pythagorean identities, 1 plus tangent squared is actually secant squared. Now when I do the square root of 4, I get 2. The square root of secant squared is secant x. That is the end of your 5-1 notes. So as a quick recap, a lot of the times you're going to start by writing with sine and cosine. One little caveat there is I would always kind of check for Pythagorean identity. So if you see anything that's squared or with 1, see if you can simplify it. If not, look to change everything to sine and cosine. Perhaps we need to factor out. We can multiply and need to multiply by the conjugate whenever you have a plus or minus in the denominator. Common denominator would be if I have a fraction plus or minus another fraction, or even if it's just like a fraction plus or minus like sine x. Something where there's at least a fraction involved with addition or subtraction. You're going to want to find a common denominator. Once you've found common denominator multiplied by the conjugate, you may come back up to looking for Pythagorean identities, rewriting, factor out. These don't go in this order. These are just the tools you have. And the last one was splitting the numerator. So whenever you have addition or subtraction of the numerator, you can split it as like that first term over the denominator, and then plus or minus whatever, the second term over the denominator.